welcome to Monday's edition of Cracking the Cryptic, where today we're going to be taking a look at a toxic puzzle, no less. This puzzle is called Toxic, and I think that's because it's got this big X in the middle of it. It looks fairly toxic as well in terms of its colours. It's by J.W. Sinclair, and the testers say this is a beautiful puzzle, and they have challenged me to solve it without using the Fistmafell ring, which is jolly mean of them indeed. I can immediately see that there is something Fistmafellian about this, but if I'm not allowed to use the ring, I don't know how difficult that's going to make it, but we shall find out in just a few moments' time. I want to start today with a little bit of a story and an appeal. This relates to my brother Mike, who this weekend is going to be attempting to run the Rome Marathon, which is the last of 27 marathons that he has run throughout the EU. He started this project back in 2015 and has been delayed somewhat, of course, by COVID and travel restrictions. But he's been doing this to raise money for ME, and it's just an incredible thing. 26 marathons down, just Rome to go. So I'm going to put a link under this video. I'm sure we all know people who have suffered with ME. It is absolutely no fun at all, and if any of you are in a position to just donate even $1 or $2, we'd be really grateful. And Mike, I wish you all the best at the weekend. Proud of you, bro. Now that's that said and done. Now I need to get my head back in puzzle solving mode. Yes, lots of you have been asking whether I can have a go at the Sudokutown Murders puzzle from Nordy and Lorik, which we published a few days ago on Patreon. Yes, I'm going to try and do it. I don't know if I'll be able to do it, but if I can do it, I will post a video on Patreon at some point in the coming days. So wish me luck with that. The feedback, those who solved it say it's wonderful, and some of the people who solve it say that it's not that hard. But there we have had an awful lot of people saying it's absolutely impossible as well. So yeah, make of that what you will. Anyway, let's get on with Toxic and see what J.W. Sinclair has in store for us. We have got the following rules. Normal Sudoku rules apply. In cages, digits must sum to the small clue in the top left corner of the cage. So normal killer Sudoku rules. We've only got 4 cages though today. Along thermometers, digits must increase from the bulb end. Well, that's a little bit of a joke in this puzzle. We have 2 very short and stubby thermometers, so that tells us if this was an 8, this would have to be a 9, because as mercury rises along thermometers, so must digits when we're talking about the Sudoku versions. Each purple line contains a set of non-repeating consecutive digits in any order, so these are so-called Renban lines. So let's imagine there was a 1 here. Then we would know that this line here had to contain 1, 2, 3, 4, and 5, because the digits have to be consecutive. But unlike thermometers, these could appear in any order, so that would be a legitimate way of filling that Renban line. And I'm guessing these are German whispers. Yes, so adjacent digits along a green line must differ by at least 5. So let's imagine we worked out that cell was a 2. Then we would know this cell would have to be 7 or more. So it could be 7, 8 or 9. Let's make it 9. And this square similarly would have to be 7 or 8 now, because it couldn't be 9. But it must be 5 away from 2. And that's how green lines work. Now, do have a go. The way to play is to click the link under the video as usual. Now I get to play. Let's get cracking. Now, by the way, if some of you are wondering what I'm nattering on about the Fistmafell ring, there is a theorem in Sudoku that tells you that those digits, those 16 digits there, are the identical digits to these 16 digits in the corner, which is pretty amazing when you first hear about it. I'm not going to prove it unless I get totally stuck and need to use it to solve the puzzle, but we've done loads of proofs in loads of videos over the years on Fistmafell. Now, I can tell you that there is a 1 in one of those cells straight away. How do I know this? Well, it's by Sudoku, because there must be a 1 in a 3-cell 8 cage. So now, having identified that each of these cages needs a 1 in it, I can ask where 1 goes in column 3, and it's not in any of those 6 cells, so there must be a 1. on the whispers line, which is not very helpful, to be honest. And I see we've got the same thing going on with 9s in the final 2 columns, because there must be a 9 in a 22 cage. Oh, I need to turn the digit thing down. People have been telling me that I can... You see this 9 is overlapping the 22. Apparently, if I change to small digit, or if I turn large digits off, yes, look, it works. I can see the cage totals. Ah, Sven, you are magnificent. So this means, yes, so we've got the same logic. 9 in here, there must be a 9 in there, so the 9 in column 7 must be on the whispers line. Again, it's sort of the digit that gives the most flexibility, because, well, what do we know about whispers lines? We know that whispers lines alternate and they cannot have a 5 on them. So why can't they have a 5 on them? Let's just prove that. Well, it's because if you put a 5 on, the next digit has to be 5 different from 5 at least. So it either has to be 0 or negative or 10 or higher, and that won't work. Why do they alternate? Well, let's imagine this cell was the 9. These 2 cells both have to be sort of the other side of 5. So they have to be a 1, 2, 3 or a 4. And then let's say this was, I don't know, a 3. This square has to, this cell now has to be the other side of 5 again. So it flips and becomes a high digit again. So those are the 2 things we need to bear in mind with whispers lines. So we certainly can say these can't both be 5, 8, 9, because that would put a 5 on the whispers line, and we've just shown that's impossible. And in fact, yes, here we go. And does this work? Yes, it does. Right. So now I can tell you. Actually, there's loads I can tell you. I'm going to start off with telling you that this cage here, whatever the composition of this cage is, so it's either 5, 8, 9 or 5, 6, 7 to get to 22 in 3 cells. This one is different. And that's because if these were the same, let's imagine these were both 5, 8, 9 for a moment. Oh no, 5, 8, 9 is silly because that's ruled out a different way. We'll go 6, 7, 9. If they're both 6, 7, 9, this string of digits is 6, 7 and 9, and that won't work because of the alternating polarity of the whispers line. We need these digits to be 5 apart, and there's no way they can be. So that tells us that whatever this cage is, if it's 5, 8, 9, this is 6, 7, 9, and vice versa. Now these work the same way. If these were both 1, 3, 4, this would be 1, 3, 4, and those digits aren't 5 apart. So these are also different. What colour shall I use? I'll use purple. Oh no, I've already got purple. I'll use red because I've got purple in the green on the line, in the grid on the lines. So each of these cages has to be different. Yes, and well, the other thing I was thinking about, but it is a Fistemafel trick, so I won't use it. But because the corners, the 2x2s in the corners, now actually contain all of the different digits of the Sudoku, because within, we can think of the yellow and the red together as a set of the digits 1, 2, 3, 4 and 5 plus an extra 1, and we can think of the digits in the 22 cages as a set of the digits 5, 6, 7, 8 and 9 with a repeated 9. So every digit must appear on the ring now, because there's every digit in the 2x2s in the corners. And in fact, yeah, see what we could do, if we were allowed to use Fistemafel, we could say there's a 5. Yes, there's 2 5s. There's 2 5. Yeah, there's a 5 in this string of digits and a 5 in this string of digits. Now, I'm not allowed to use Fistemafel, at least not yet, but that's what we could say, because we know there's a 5 in one of the 8 cages and there's a 5 in one of the 22 cages, there must be 2 5s in the ring, and the 5s can't go on the green lines, so there must be one there and one there. There we go. But I'm not allowed to use. No, we don't know that. We don't know that. We can't use that to our advantage. So how do we do the puzzle? That's the next question. Can we somehow... I haven't got a clue, actually. I have not got a clue. I don't think... I was wondering whether it's somehow possible to work out the polarity of these lines. When I say the polarity, I want to know where if I could work out where the high digit was on here or where the low digit was, then I would know the line would alternate, and that would give me a way into thinking about these Renban lines. I have a horrible feeling there's something I'm meant to be able to deduce. You know, if I work out that's high, perhaps that has to be low in order for the Renban to work. But given the Renban can be in any order, that might not be true. My mind keeps being dragged towards Fistimofel, which I'm not allowed to use. That can't be a 9. Why have I got 9 in there? That's on a thermo bulb. Right, okay, that digit's a little bit high then, isn't it? Because this digit must be at least a 5, so that digit's at least a 6. And it can't be 9 because there's 9 in the bulb. Good, right. I like this. I like this because it's very unusual to see a short, stubby thermometer have any role in a puzzle until you get to the very end. Normally, short, stubby thermometers are used to disambiguate deadly patterns, and I had assumed that that's what was going on here, but it's not. This is interesting because this digit is is clearly not blue. It must, because it's a high digit, it must exist in orange. So you can see, imagine this was 589, then, well, in fact, that would have to be a 6 or a 7, and this is 679, so that this digit has to be that digit. So so that digit's not 9 either. Let me get rid of that and put 678 in, and these two digits are the same digit. So let's give those a bit of, black flash is a bit ugly, isn't it? Having a bit of a chromatic issue today. So these are grey. Now, why is this interesting to me? Well, now I've got grey in one of those cells, and that means that this little tiny string of 3 cells contains a 9 and a grey digit, i.e. it contains 2 high digits, and the 2 high digits can never be adjacent on a German whispers line because of the need for them to alternate. So those squares, so this is not 9. These 2 squares are high digits, and they are a 9 and a grey digit, so I don't know which the order is, but that means these 3 cells have got to be low digits, and that gives us 1s, 2s, 3s and 4s on the purple lines. Now, what is that doing? So I'm not allowed to use Fistimofel, so I was wondering if I could do a count of the 1s. Actually, let me just think about that for a moment. There's a 1 here. It depends whether I'm allowed to use Fistimofel or not. But I was wondering whether I could now state with certainty that there must be a 1 on one of those Renban lines. I don't think that's necessary. I think this might be able to be a 1. If there is a 1 on a Renban, of course, it's very powerful because we then know what the Renban's got on it. It would have to be 1, 2, 3, 4, and 5, which is a little bit difficult, I can see. Well, in fact, it's absolutely that's not 1. No, this is not 1. Right, that's a little bit interesting. That can't be 1, because if this is 1, this is 2, 3, 4, 5, and there's not enough space for those digits in this box. You can put a 5 in the 22 cage, but no other low digit. So these 4 digits here would have to occupy those 2 cells and 1 other i.e. the 5 can go in the 22, and that won't work. So that's not a 1. And indeed, there is no 1 in this Renban at all now. We already knew there was no 1 here. There's no 1 in these 3. So does that mean this has to be a 1? Does the same logic work with this one? If that's a 1, you get 1, 2, 3, 4, 5. You've not got the thermo here, though. Okay, no, it's the same, actually. No, okay, Simon, use your brain. Right, no, you don't need anything complicated to eliminate 1 from either of these cells. All you have to note is you've got three low digits in column 7 already. So you can't put 2 low digits in this domino, and you can't put 2 low digits in that domino. So if we're saying all of these 4 digits here are the numbers 1, 2, 3, 4, and 5, we have to not put, well, we can put 5 in the 22 cage. That's as efficient as we'll get. But let's actually put this in. I think it might be clearer if I put it in. If this is 1, 2, 3, 4, and 5 somehow, because this is 1, how on earth does this work in this box? I've got to put 2, 3, 4, and 5 into these 3 cells, and I can put 5 in here. So I must put 5 in here, and then I've got to put 2, 3, and 4 in those cells, and that's too many low digits in this column. It's nonsense. So that is probably useful because it gives me my first digit in the puzzle. Because now I've worked out this square is not a 1, and if that square is not a 1, oh no, no, it only gets me 1 if I use Oh no, it only gets me a 1 if I use Fistamafel. Oh, you rotten thing. The way to do it using Fistamafel is because I know there's 2 1s on the ring. And I've just proved there can't be 1s in the purple. And there's a 1 there, so there must be a 1 there, and it's there. I don't like this way of having to solve Sudoku. It feels like I'm having to do it with one hand tied behind my back. Right. Okay, no, I can still do it, actually. It's probably a sort of an implication of Fistamafel, but where does 1 go in that row? It's got to go here. Where does 1 go in this row? It's got to go there. So the 1s, we can now ask where 1 goes in column 7, and it must be in those 3 cells, and it must therefore be there because we know these are high digits. Okay, so we have got our first digit in the puzzle. It is this one, and I didn't use Fistamafel to prove it. But that's a Renban with a 1 on it. So that's a 1, 2, 3 triple, which, well, that cannot now be, no, that clearly can't be 2, because if that's a 2, there must be a 3 on this Renban, and that would require both of these cells to be 1, and that won't work. So that's not 2. So this is 3 or 4, and whatever it is, we've got to be very careful here. So if this was 3, this would be a 1-2 pair. These would be an 8-9 pair, because this would have to be a consecutive sequence. That might be fine, actually. Oh, no. Right, this is actually beautiful. Right, the key here is we need to consider the implications of both of these cells together. That can't be 4, because if it's 4, where are you putting 4 in this box? And the answer is there. So if this is 4, I have to put 4 in here, one of those 2 cells. How on earth do you fill this line now? It's impossible, because it has a low digit on it, which is this one, a 2 or a 3, but it's got to contain consecutive digits, but it can't pass through the 4. So it would have to sort of go into the realm of negative numbers, which won't work. So this is not right. This is a 3, which means that's a 3. We get a 1-2 pair. We now know those are consecutive, and because they can't include 2, they are 4, 5, 6, 7. This is 8, 9. This is on a Renban, so this is 7, 8, or 9, depending on what this one is. And This by Sudoku is 3. This is not 3, this is 1. So this is 1 and this is 2, and all of a sudden... No, I'm not saying anything, but it got quite exciting for a moment, didn't it? So now there must be a 2 and a 4 in this string of digits. So yeah, so 4 in this box is 4, so that's got to go there. Which almost feels like it's important. So these 2 digits are the same. Ah, okay. Maybe we now use the whisper. This is a 3, so this has to be at least 8 because it's got to be 5 away. Then we drop down to 1. So if this was 4, this would have to go 9, 1, 8, 3. If this is 4. Why does this have to be 4? Because it can't be 2. It's because it can't be 2. It cannot be 2. Because if it's 2, there's got to be a 3 on the renban, and we've already got a 3 in the row. Aha! There you go. So this is 4. There's no 3 on the line, so we now know the contents of this renban, 5, 6, 7, and 8. This is a 2, oh, this is a 2, 9, but this is a beautiful puzzle. This is just beautiful. Now, this being 2, 9 tells us the nature of the red cage. That's got to be 1, 3, 4, because it can't have a 2 in it, which means this one up here is 1, 2, 5, which means that's not 5. Now, what does that mean? This is on the German whisper, so this can't be a 5. So this is high, and that tells us the parity of this line. Beautiful. So, oh, which actually, no, it is beautiful, but I just realised I could have got it from knowing that the 1 was in one of those 2 positions. That was also telling me the parity of this line. Well, never mind, we got it 2 ways. Now, what we can't do is put 4 in either of those cells. Because if you put the 4 in the middle of a whispers line, think about what digits you have to have on either side of it. They both have to be 9s to be 5 away. So that won't work. So these are only able to be 1s, 2s, and 3s. This has to be a high digit, which again, that's also a little restricted. This can't be 6, or you'd have to double 1 the other sides. And that would be silly. Now... can we do something with this? Yes, this can't be 3. That can't be 4. It's got to be a high digit. So this is a 6 or a 7. Oh dear. Okay. It was nearly good, but I don't quite see how we're going to resolve this. No, I really don't. What can we do? Ah, I know what we can do. We can do Sudoku. Whenever I'm stuck, that's really should be my mantra, shouldn't it? So we've got 4s in those positions, which means there's a 4 here. That's on a whispers line, so that becomes a 9. That places 9 in the orange, which... probably useful somehow, some way. Don't know. This is 6, 7, or 8. So let's think about it. So this is 5, 6, or 7. And it doesn't actually seem to see anything to rule. Oh, no, I see how it works. This can't be 8 because this can't be 5. And therefore 8 in the box has to go there, which is in orange, which makes that 5. That means this is 8 down here. And this has to be 6, 7s, and 9s. We can't put 9 in the bulb, so this is 6 or 7. And there must be a 5 in this domino by Sudoku. And we can... Right, so these 2 digits we now know. They're a 2-5 pair. Oh, I see. They're a 2-5 pair where you can't put 5 on a German whispers line. So that's disambiguated straight away. So this is 2. This is 5. 5 in that box goes here by Sudoku. So these squares... Oh, I see. Yeah, lovely. This is 8. It must go there by Sudoku. So that's got to be a 6-7 pair. I can see that's giving me a 6-7 pair in this column, which means that's not 7, and that is now 9 in fact, because it's also not 8. So this digit is rather annoyingly very... Oh no, it's not annoying. I was going to say rather annoyingly it's low and it's on the thermo, but it is low, but it can't be 1 or 2, so it is 3, which means this digit is 6 or 7. That's not a whisper, it's a thermo, so we can't rule anything out there. So we've got 6, 7 pair here, and I don't know what we're meant to do with it. Oh, and a 6, 7 pair there, so that's got to be 9, which means that's not 9. I've got a 6, 7 pair here. And let's have a think about this whisper line then, because this has got to be a high digit, and it can't be 6 or 7, so that's got to be 8 or 9, and then that's got to be low again, so that's got to be 1, 3 or 4. Right, that's still useful, because now I've got a 1, 3, 4 triple in row 9, which means this is an 8 or a 9, and it's not 9, so that's 8, that's 9. 9 is in the middle box there. This is not 3 by Sudoku, so I've got a 1, 2 pair on this whisper line, which is only going to be useful. Well, if I could get that digit, if I knew that digit was a 2, it would force this to be a 7. Oh look, I've got 8 and 9 looking at that square, so that's 7, which means that's 8 and that's 9 using the rem band. That's 9, that's 2, that's 2. This is just gorgeous. Now that can't be 1. So this, this is good. Yeah, this is good. This whisper line here can't have 1 on it, and it can't have 2 on it, and it must have a low digit on it, so it's a 3 or a 4. Now if it had 4 on it, it would need to have 9 on it, so that's impossible. So that's 3, 8, which somehow, does that resolve? So I'm looking for Sudoku to help me. I'm not sure it does actually. Okay, but this column, it resolves that one, I see. Okay, so we get that digit, which means this digit is not 4. This square here, I think we just ask where 7 goes in this column. It's got to go there. So that's 7, that's 6. Therefore that's 7. We get a 4, 5, 6 triple on the ring here. We get a 5, 6, 7 triple on the ring here. And this box still needs 4s, 5s and 6s in it. And that can't be 5. Oh, in fact, that's a naked single now. So that's 6. This is a 4, 5 pair. That's 6 by Sudoku. This 5 is helping me with my 5 and my 1. Yes, we just have to do a bit of tidying up. 3 6s and 7s into here, so the 6 must go here. This is 3 and 7. That's a 7 by Sudoku, which we could have got from that column, but I wasn't looking there. And this is 1, 2 and 8. And that might be helpful. I'm not sure. I still not used the cross actually. That's a bit strange. Okay, hang on a minute. Let me just have a stare at this for a second or two. How do I disambiguate this 6, 7 as well? I don't know. So this is 5, 6 or 7 here. Oh, I see how you do it. I see how you do the middle bit anyway. This square can't be a high number. It sees 6, 7, 9 and 8. So that's a low digit, which tells us the parity of the whispers line. This can't be a 4 because it would require a 9. So this is just 1, 2 or 3, and it's not 3. So this is a 1, 2 pair. Oh, that's bravo. This is lovely. Now 5 can only go there, which means this is 4. Now this whispers line then, this is a high digit, which is not 9. So that seems to have, it can't be 6 because you'd have to double 1 the other sides of it. So that's 7 or 8. Oh, this is gorgeous. It can't be 8 because 8 and 5 can't be consecutive on a 3-cell Rembrandt line. So that just is 7. That's 6. And the 7 gets me a 7 at the top, which means that's a 7. This is quite exciting now. So this has got to be a low digit, and it's got to be a 1 or a 2 because it's got to be 5 away from 7. So now in this box, I've not put in 3s, 4s and 8s. So there's definitely a 3 in one of those squares. This is definitely a 4 or an 8, which probably is resolved somehow. I can't see. This 3 is giving me a 3 here. That's now an 8. So that places the 8 here. So that does get resolved. This is a 3-4 pair. This is a 4. This is a 5. I'm better with these smaller digits. This is a 6. That's a 6. That's a 7. That's a 5. This is a something. Don't know what. 6. No, 7. There we go. It's a 7. And that should be a something. A 2. Okay, so that column looks done. That box looks done. This 7 is removing itself from here. This 5 is helping me finish that. 5, 6. That's therefore 4. 5, 6. So this is 5. This is 6. I've got a 1, 2 pair in this column. So this has got to be a 3 or a 4, I think. Which is not as helpful as I was hoping. This can't be 8, look. So 8 can be placed. Oh, this 3 at the top gives me a 1 here. So that resolves the 1 and the 3. These squares are 2s, 3s and 4s. And we can get rid of 3 from that one. Oh, see, the 1 is bouncing up the top. So that goes in, that goes in. This is now a 3. This is a 2, that's a 3, that's a 4, that's a 2, that's a 1, that's a 1, that's a 2. Wow. I think that might be correct. Yay! Yay! Not so toxic after all, J.W. Sinclair. Just very, very beautiful. That was very clever. And actually, I'm quite pleased that that I didn't use Fistamafel to solve it, because I'm not sure. Well, you clearly didn't need to. And it would have sped up a few deductions. Like I would have known there were 5s on these 2 cells. No, I would have already known there were 5s. These are 5-cell REM bands, so they had to have 5s on them. It might have given me... Might it have given me that 1 more quickly? Perhaps. Perhaps it would have done that. But I still think we'd have had to think about the nature of these REM bands and how many low digits they can have on them, in order to understand, certainly to whittle that down to being just able to be 3. It's really fascinating, isn't it, how these different rules can interplay when done properly. Yeah, really like that. I hope you did too. Let me know in the comments. I do enjoy them, especially when they're kind. And we'll be back later with another edition of Cracking the Crib.